Welcome back to the Multiverse series. In this episode, we're diving into the mind-blowing concepts of cosmic inflation and bubble universes. But don't worry, we'll keep it simple and easy to understand. By the end of this video, you'll have a solid grasp of what cosmic inflation and bubble universes are, and why they are so important in understanding our universe. Now, let's talk about inflation. Cosmic inflation is like that moment when the balloon suddenly starts inflating super fast. But in our universe's case, it happened right after the Big Bang. It's a theory proposed to explain why the universe is so vast and uniform. At the very beginning, right after the Big Bang, our universe was tiny, hot, and dense. But then, cosmic inflation kicked in, causing an incredibly rapid expansion. Picture it like this. Imagine you have a tiny dot of paint on a piece of paper, and then suddenly, the paper stretches, making that dot much larger. Cosmic inflation stretched our universe so rapidly that it became much larger than we can even comprehend today. Now, you might be wondering, why is cosmic inflation so important? Well, here's the deal. Cosmic inflation helps explain why our universe appears so uniform. Before inflation, different parts of the universe couldn't have communicated with each other because they were too far apart. But the rapid expansion caused by inflation made them closer, solving what's known as the horizon problem. Think of it like this. Imagine you and your friend are on opposite sides of a huge football field, and you want to coordinate your dance moves. It's impossible because you can't see each other. Now, imagine the field suddenly stretches, and you're right next to your friend. That's what cosmic inflation did for the universe. Cosmic inflation also predicts the existence of something called the cosmic microwave background, or CMB. It's like an echo from the Big Bang, a faint glow of radiation that fills the universe. This CMB radiation is crucial evidence that supports the theory of cosmic inflation. Imagine you shout in an empty room, and the sound waves bounce back to you. The CMB is like those sound waves, giving us clues about the universe's early moments. Inflation didn't just stretch the universe, it also created tiny fluctuations in its density. These fluctuations were the seeds for the formation of galaxies and galaxy clusters. Think of it like planting seeds in a garden. The universe's inflation planted the seeds that eventually grew into galaxies, stars, and planets. So there you have it. Cosmic inflation explained simply. It's like the secret ingredient that made our universe what it is today. Think of bubble universes like soap bubbles in the cosmic bubble bath of the multiverse. Each bubble represents its own universe, with its own set of physical laws and constants. But how do we get these bubble universes? Let's break it down. Imagine the early universe as a pot of boiling water. This pot represents the vastness of the multiverse. Now, every once in a while, a tiny bubble forms on the surface of the water. That bubble is like a baby universe being born. These bubbles are like pockets of space with their own unique properties. Some might have different laws of physics or constants than our universe. Now you might ask, how do we know these bubble universes exist? One compelling piece of evidence comes from studying the cosmic microwave background radiation, or CMB for short. It's like the afterglow of the Big Bang. Imagine you're in a dark room, and you see the shadows of objects on the wall. Those shadows hold clues about the objects. Similarly, the CMB holds clues about the early universe and the possibility of bubble universes. Scientists have found unusual patterns in the CMB, subtle variations that can't be explained by our universe alone. These patterns could be the result of interactions with neighboring bubble universes. Think of it like two soap bubbles touching. They might merge or interact in interesting ways at their boundaries. And there you have it, bubble universes demystified. If you enjoyed this episode of the Multiverse, don't forget to like, subscribe, and hit that notification bell